Right, so we are now looking at the last part of this topic, which is the manufacture of aspirin. Yeah. Now we all know aspirin is a common painkiller. Yes. You can buy it over the counter. You don't need a doctor's prescription. It's a well-known painkiller. Now, you will be expected for this exam to know the synthesis of it. It's only one step, and this is how we make it. So you take salicylic acid, and what I'll do, I'm putting a benzene ring, I'll put the circle, I'm allowed to put a circle or 3 carbon-carbon double bonds. You already know, I'm going to remind you one more time, that the circle represents 6 pi delocalized electrons. So with salicylic acid, we have a carboxylic acid group right at the top, and then there's OH, phenol. So what I want to do is put its name for you, salicylic acid. You got to know that. Okay, we react that with that fellow over there, the acid anhydride. Okay, you will be expected, why would you use ethanol chloride? And I'm coming on to that. So do you mind if I put it like this? Yeah, that's fine, isn't it? Like that. There we go. It's balanced. The questions I've seen on the exam papers, there's a dotted line that's missing, and they're giving you that and the product, and you have to do that. But part of it is equated, but I can't really guarantee. Because strictly speaking, if we learn the whole thing, then we're not going to have a problem in the exam. So what happens is that this acid anhydride, as you can see here, the that O will act as a nucleophile and attack this carbon right here of the carbonyl group. And as it does so, you're going to form an ester here, and this is what we end up with. So the benzoic acid group is still there, and then you end up with this ester here. Okay? Plus, you will end up with, if you look at it, 1 molecule of ethanoic acid. And the reason, if I go on this side, I can show you. So what's happened is this part of the molecule here, you see that, has joined on to that. The H has come off and linked to there. You see that? How cool is that? Do you see that? So let me repeat that again. So as it's attacked, you see this part has added to that oxygen of the phenol group. Can you see there? So this part is just this part here. And what you're left with, you were left with that. Now the H that joins onto that has come off from there. Does that make sense? Yeah. And this is perfectly balanced. So as I recap, the 2 questions I've seen is there was a dotted line on there and dotted line on there. And this is also true for the OCR exam paper when I was looking at that, the A level. But I can't really guarantee. So I would prefer you cover that. And this is the structure of the drug aspirin. Okay, that's the structure of the drug aspirin. So now we look at the advantages. So that's what they're going to ask in the exam. So what are the advantages of using ethanoic anhydride instead of ethanyl chloride? Now, if you've forgotten the structure of ethanol chloride, I'll remind you again. There he was. You see? And what did I told you about this? It's incredibly reactive compound. It reacts with moisture. It's very moisture sensitive. So, as I said, I'll put this in color. I think it will stand out. So the main advantage is, the first one is no toxic fumes or harmful, whatever you like, of HCl gas are released. Yes? Are you happy with that? You can clearly see on the top. Can you see any HCl gas? No. And remember, when we make aspirin, when they make aspirin in companies, pharmaceutical companies, they don't make it on a few gram scale. They're going to make it on tons, because it's a common painkiller we can get from supermarkets. So you don't want to really toxicate your workers, basically, think logically. So that's why it's safer to use the ethanoic anhydride. The second one I've already touched upon and that is that ethanoic anhydride is not moisture sensitive. Well, certainly it isn't as ethanol chloride was, okay? So that is the second one, so we don't need to worry about moisture getting in the way, okay? So those are the two main things we need to know. The second one is, as I've already said, is the practical now. Proving the purity of aspirin. Okay, now how do we go about that? Well, the answer is we're going to measure its melting point. Okay, so essentially measuring the MPT. Are you happy with MPT? So you know that means melting point. So measuring the melting point of a crystalline sample of aspirin and then comparing the melting point with literature. Now, literature means information taken from the internet, or it could be a journal, or it could be a textbook. And when I do that, so what? What about that? Well, what I'm looking for, and this is the key on your spec, it says that the candidates need to be aware that when the melting point range that you measured in the lab is narrow, in a narrow range, narrow means it's very similar and it's not too wide to the literature value, the aspirin is pure. Okay, so the melting point range of the aspirin must be in a narrow range, and narrow range and within the range quoted or given in literature. And this will suggest aspirin is pure. Okay, happy with that? Right, now is that 4-mark thing I just said. How are you going to go about? So this is the subtitle, how to measure the melting point of aspirin. Now, I'm not going to draw any instruments. I will put something on there that you can look at, but there's no need. The key thing is I'm only interested in the method, so just put the method down and get your marks, that's it. It's quicker that way. Okay, the first thing is, now that you have your aspirin, you got crystals of aspirin, let's say you crystallized it, all that, we're going to grind it into a fine powder using, so grind the crystals of aspirin into a fine powder. Step number 2. Now, what we use here, if I show you on this side, it's a capillary tube like this. It's the same one that you use in chromatography, but the chromatography one is open at both ends. Do you see that? This one is sealed at one end. Now, you know, in labs, I used to have a student which I used to teach in Wednesbury, Sophie, and Sophie's actually gone to the University of Bath to do pharmacy, so she's got into her first choice. And Sophie said that, you know, with her, in her A-level class, they used the normal capillary open at both ends. What you do, you hold it in the center of a roaring Bunsen flame, and at this end, not that end, otherwise you're going to burn your fingers, and you twist it around like that. So as the glass gets hot, and as you twist it, it will melt and it will curve at the end. How cool is that? Okay, but usually basically the laboratory technician at your school should normally do that for you, but if they do, so it's got to be sealed because we don't want the powder leaking. Does that make sense? So what you will then do is pack, and that's the key word, pack the aspirin. Pack the aspirin powder into a thin glass capillary tubing. So you will end up with something like that. Can you see like that? Happy? So you don't need to draw that in the exam. And then what we used to do is to get it like that, so it's up there, so we used to dip it down at the open end, get it like that, and then what we used to do is tap it on the bench like that. And as you tap it, the powder is drawn right at the bottom. Makes sense? Then number 3, what you do is, you know, if you look at the plan view of a melting point instrument, it has 2 holes. So basically you've got a small hole at the front and there's a big hole there. Okay? Again, don't worry about that. The back one is for the temperature, thermometer. And the front one is for the capillary tubing with your sample. So step number 3 is place the capillary, this pen is sort of giving way, capillary tubing into the melting point, am I right? Yes, instrument. In the smaller hole, and then number 4, place a thermometer in the larger of the holes to measure the temperature. And then finally number 5, fifth step, and that is when you look at the melting point instrument, there's a viewfinder, you know, like a magnifying window. You look through that, you turn it on. As you turn it on, a light appears, and what you'll see through that magnification window is there's your sample. You'll see it right there. Does that make sense? But it's actually a zoomed in image, and you got light coming as well. And what you do, you keep staring, keep looking, and what you're looking at is the point at which the solid just melts. And at that point, quickly look at the back of the thermometer and take the reading. Make sense? So look through the glass window on melting point instrument, and as soon as the aspirin melts, record the reading on the thermometer, and then what you can do, repeat experiment several times, and that's it. As I said, twice it's come up on this exam board, and it's been 4 marks on both of those occasions. Does that make sense? Right, the last of the questions that I want to look at, and they ask you, how can you purify? So you've got, like, they'll say that this is more likely to be on paper 3, and that is that essentially, how can you purify a crude sample of aspirin? Again, this was 4 marks. So this is the last one, how to purify a crude, that means impure, crude, that means impure sample of aspirin. Okay, and as I said, look, it's very simple. It's what you've learned in your GCSE essentially. So first of all, dissolve the crude aspirin in the minimum amount of hot water. You could go for water or aspirin because it's got to be soluble in it until it dissolves. And the reason is this helps to dissolve, or just say this helps to get rid of insoluble impurities. Then number 3, allow hot solution, because it's going to be very hot, to cool slowly to room temperature. There we go, temperature. And then step number 4 is that filter the crystals of aspirin and wash. Now be careful, don't go over the top. You got to wash with a small amount of water. You do too much because we know this is a drug and it's soluble in water, you're going to dissolve the whole thing. So filter the crystal of aspirin with, and wash with small amount of distilled water, free of bacteria. It's good to say why examiners are looking for the candidate, why you did that step. So to help dissolve the soluble impurities. And then finally, what I like to always add, how you're going to dry the aspirin. So dry the aspirin using a desiccator. Yes? And a desiccator, if you look up on the internet, you will see it's a device, it's a jar. You've got your drying agent at the bottom, you seal it with a vacuum. It is not an oven, please note. If you put it at an oven at 100, you're going to melt the crystals of aspirin, okay? So oven is good, but it's not good for everything, especially for crystals, it's not. So a desiccator is better because it's at room temperature. The drying agent at the bottom, we used to use P4, technically use anhydrous copper sulfate, will dry, yeah? And that covers that.